Okay, so we are going to, in 2B, we're going to get a little bit more into unit analysis, looking at different systems and going from there. Okay, so there are basically two ways of measurements in the world. There is the metric system, and there is what we're going to call the US customary system, which some people call the imperial system. So the rest of the world uses metric, and even some things in the United States we still use metric. If you want to see how a little kind of a breakdown on where we're at and how other countries are in on the metric system, you can go to this website and type it in, or if you open up um, the electronic copy of the notes, you can just click on it. It's actually pretty interesting if you're curious to see what that is. Okay, some basic units in the customary system, different lengths. We have inches and feet, yards, sometimes measure in rods or fathoms, furlongs, miles, nautical miles, and leagues. And so these are some of the conversion factors among the lengths. Some conversion factors among weights. There are 3 different types of weights, grains, or the avoirdupois, troy, and apothecary. We're not going to use a ton of this information, but it is there for you. And then liquid measures here. Okay, another thing we're going to talk about here is what's called unit rates. Unit rates are a great way to compare different things to figure out which one might be the better value. So we call it a unit rate because it is the cost of one measure of an item. So 1 unit. So whether that is per 1 foot, per 1 square yard, per gallon, per pound, per dozen, or whatever. So it's always going to be like a currency, which in the United States is going to be dollar per whatever unit you want to measure in. So you're going to find this in multiple different things, and you can compare them that way. So I use it mostly when I go grocery shopping, but also when I do any kind of shopping, really, if I want to compare which one's going to save me money. So you can compare 2 brands, you can compare different sizes, and oftentimes in like the grocery store, they have a tag that has the unit price in it. It'll be written smaller, usually in one of the corners. Sometimes it's helpful, sometimes it's not so much. Sometimes it's just like $1 per, whatever box it is, and in which case, it's the same thing as that, the main price of the item, so it's not really helpful, but sometimes it is. So in this case, let's say you're buying brown rice. It's a 3-pound bag of rice or box of rice, and it costs $3. So $3 will be to to buy that entire box of brown rice, and this is how much you get in it. Now the unit price here is going to tell you the dollar per pound. So if you're comparing, let's say a 3-pound box versus a 5-pound box, you can compare the 2 unit prices to figure out which one you'd rather have. So here, let's say we're looking at carrots, and there are 3 different options for buying these carrots. We can either get a 16-ounce bag of baby carrots for $2, we get a 2-pound bag of regular carrots for $2.29, or we can get a 5-pound bag of regular carrots for $3.29. Well, if we compare the unit prices here, they're all per pound. This is $2 per pound. This is $1.15 per pound, and this is 66 cents per pound. Well, if I'm shopping and let's say I need a lot of carrots, I might go with that one because it is a lot cheaper per pound of carrots. So let's practice actually finding that number for ourselves. So let's say we have this jar of caviar. It costs $853.65 for this 8-ounce jar of caviar. Well, what is that going to be per ounce? So remember, per in math means division. So we want a cost per unit. So we want our cost of $853.65 per 8 ounces. So I do $853.65 divided by 8, and I get $106.60 71 cents per 1 ounce. So this caviar for each ounce is going to cost me $106.71. Okay, for P, we have a thing of wrinkle smoothing cream. This is $119 for 1.7 fluid ounces. So let's see what the cost of this is per ounce. So again, we have the cost per ounce. So we have 119 divided by 1.7 to get $70 per fluid ounce. So the caviar is 106 per ounce. The smoothing cream is $70 per ounce. Now let's look at the honey. So the honey is $10.50 for 8 ounces. Now this is the same amount as the caviar. You can tell it's definitely much cheaper, right? But let's see exactly what that unit cost is. So again, we're going to take the cost for all of it. So it's $10.50 for the entire thing of honey, which is 8 ounces. So this is kind of like the conversion, like 12 feet in, or 12 inches in 1 foot, how we put it as a fraction, because they are the same thing on top and bottom. Well, here we're talking about the same jar of honey, just two things about that honey. We have the cost and the size. But to get the unit cost, we're actually going to do the division. So we have $10.50 divided by 8 to get $1.31 per ounce. Okay, so again, this is just talking about better deal. So a better value, the best buy, the better deal, they're all kind of mean the same thing. What we're going to do is we want the item with the cheapest unit price. So in this case, for the three we found here, the honey is definitely the better value because it's only $1.31 per ounce, whereas these are $70 an ounce and $106 per ounce. So let's look at some more examples here. So example 1, you can buy a box of 150 Sharpie pins for $165, or we can buy a dozen pins for $13.50. Okay, so if we want to know the better buy, we need to find the unit cost for both of these. So we want our unit cost, so we're going to want a dollar amount per something or other. In this case, we're looking at pins, so we want to find the amount for 1 pin. Okay, so we're going to need to find that for both options. So our first option, we can buy 150 pins for $165. Now notice I wrote this way just because that's the way it was written here. But remember, we want dollars per pin, so I'm actually going to switch these around to get the dollars on top. And I already have the units I want, dollar per pin, so I'm just going to go ahead and do that division. 165 divided by 150, and we get that is $1.10 per pin. So each pin in this box is going to be $1.10. Now let's see what it would be if we buy a dozen. So in this case, our option 2, we have a dozen pins, which a dozen means 12 pins. And that costs $13.50. Now again, was writing this in order, which is not the order we actually want. So I'm going to switch that, put the dollars on top. So $3.50 per 12 pins. And then we do the division, and I get that is $1.13 per pin. So if I buy the 150 box, I only have to pay $1.10 per pin, whereas option 2, if I were to buy, this is $1.13 per pin, so if I were to buy 150 either way, I would spend more money on this one. So in this case, option 1 would be our better buy. Now of course, if you don't need 150 pins, you might not want to buy this one, but if you want a lot of pins and you want to save money, that's the one you would go to. Okay, so example 2, let's say you're renting a storage locker. You have $30 per square yard per month, or you have $1.90 per square foot per week. Okay, so we have a couple different things going on here. because we have a per square yard per month, or we have a per square foot per week. So remember, so division, or per means division. So let's say we're looking at this $30 per square yard for this first option. Now per also means division, right? So we're going to have this and we're going to divide that by a month. Okay, when you're dividing with fractions, that's the same thing as multiplying by the reciprocal. So keep, change, flip. This first one stays the same, division comes to multiplication, and then instead of just month, it's going to be 1 over month. So this really becomes $30 per yard times month. And you'll notice that anytime we have two pers, you're going to put those two pers, both of them, in the denominator. So we have $30 per square yard per month. And same thing here, we have $1.90 per square foot, and we have another per, so I'm going to keep that in the denominator. So square foot times week. Now to compare these, we're going to have to get them in these same units. Right, so we're going to have to change either square foot to square yards, or vice versa, and then we need to put either the week or month. Okay, so let's say, let's try to put this into square yards per month. Okay, since that's already kind of, that's the first one, we'll just keep the first one and we'll just fix the second one. So in this case, we know we want dollars and we want square yards per month. So I know I need to start with dollars, so I'm just going to go ahead and start with this one because it already has the dollars in the numerator. And I'm going to fill out the rest of the table here. So I know I don't want square foot in my answer, I want square yard. So I'm going to first take care of the square foot instead of the week. So I need to have something in my, something to do with square foot. Now I do have a conversion between feet and yards. So I know that there are 3 feet and 1 yard. But here I'm looking at square feet and square yards, which means I'm going to take my normal conversion and square it to get 9 square feet and 1 square yard. So I have 9 square foot and 1 square yard, so that means my feet squared cancel. And now I have week, but I want month. So we'll just kind of estimate that there are 4 weeks out of every month. So I'm going to put the 4 weeks on top because I want the weeks to cancel. And 4 weeks is equal to 1 month. So now we have dollars in the numerator, which is what I want. We only have yards squared and months in the denominator, which is what we want. So I can go ahead and multiply here. So $1.90 times 9 times 4. To get 68.4 per square yard per month. So now we have the same units and we can actually compare, and we can see that the storage locker for $30 per square yard per month is going to be cheaper than the $1.90 per square foot per week. Okay, let's talk about the metric system. Okay, the metric system is really nice because it goes in factors of 10, which is how we count, right? With each place value increasing by a power of 10. So the metric system does a lot of that. It's similar to it, and instead of having different names like, you know, feet and inches and yards and miles and all that sort of stuff, they have the same unit for different things. They just add on a prefix to tell you how big or how small it is. So in the metric system, when you're talking about length, if you're going to have units in meters, and it's abbreviated with an M. For mass, which is like a weight of something, they use grams, and that is abbreviated with a G. For volume, they use liters, or sometimes it is spelled RE, depending on where you're at. And that is a capital L. Okay, so that is the basic unit. And then you add the prefix to say how big or how small that is. So we have kilo, hecto, deca, the basic unit, deci, centi, or milli. So the ones here on the left, those are big units. So like a kilogram or a kilometer, that's a big unit of measurement. And these small ones like centimeter or millimeter, those are smaller. So we do have a mnemonic to help remember the order. King Henry died unusually drinking chocolate milk, where of course the first letter corresponds to the prefix. Now notice we do have two D's. We have a deca and a deci. They do have slightly different abbreviations. So deci is just going to be a D. For deca, you have a DA. Notice that all the small ones have the I at the end. And the bigger ones, they don't. They have O or A. And as you move among this chart, let's say you're going from just a basic meter to a millimeter, each time you move to another column, you're going to move the decimal point. So if you're going right in the column, you're going to move the decimal point to the right. If you're going left in the column, or left among the chart through the columns, you're going to move the decimal point to the left each time. So move it to the left, or divide by 10, move to the right, or multiply by 10. So for some examples, let's say we have 0.521 millimeters. So millimeters is all the way here, and we want to go to meters. So we're going to the left from millimeters to meters. So we go 1, 2, 3 places, which means we're going to move this decimal point to the left 3. 1, 2, 3, and fill in the zeros. So this is going to be 0.000521 meters. Okay. Now, for example, 4, we have 9501 grams. We want to go to kilograms. So now we are starting with just a basic unit because there's no prefix, and we're going to kilograms. So again, we're going to go left 3. So for a whole number, the decimal is point at the end. So again, we're going to go left 3, 1, 2, 3. So we have a 9.501 kilograms. Okay, example 5, we have 40.06 liters. And we're going to go to milliliters. So we're starting from our regular unit because there's no prefix. And this time we're going to go right to milli. So we go right 1, 2, 3. So start here, we go right 1, 2, 3, and add a 0. So we have 40,060, so 40,060 milliliters. Okay, example 6. 1457. Now this is a D, but there's no A in there, which means it's going to be deci. So it's decimeter, and we're going to go to hectometer. So we go on deca to hecto. So again, 3 to the left. I'm going to go 1, 2, 3 to get 1.457 hectometers. Okay, example 7. This time we're starting from hecto, and we're going to centimeters. So we start hecto, and we're going to go to centimeters. So that's 1, 2, 3, 4 this time to the right. So we start here, we go 1, 2, 3, 4. Fill in the zeros, so we have 2, 1, 1, 2, 3, 4, 5 zeros. So we have 2,100,000 centimeters. Okay, and the last one, we have 448.5 centigrams, and we want to go to grams. So centi to the normal unit is only 2 to the left. So we go over 2 to get 4.485 grams. Okay, now let's say we need to convert between the US system and the metric system. Well, here we have conversions. And just like we did with the currency, you can use either way. So this first one, we're going from the US to metric, so we start with 1 unit of the US, and it tells you how many are in the metric. Or metric to US, it tells you 1 of the metric units and how many of that in the US system. You can pick whichever one you want to use depending on which number you want. So for example, 9, let's say we want to go 34 pounds to kilograms. So we want kilograms, which means that's going to go first in my table. So I need to know the conversion between kilograms and pounds. Now, I can either find the pounds and kilograms here, so I would need either this one or this one. And which one you use really, again, doesn't matter. I am going to pick this one because this only has 4 digits and that one has 5. But again, it's really up to you. So with kilograms is a 1, and with pounds is 2.205. And now I want kilograms, I don't want pounds, so I need something to put up here to cancel it out. And I have 34 pounds here. And nothing else with it, so I'm not going to put anything here. You can put a 1, or you can just, cross it off, whichever one you're more comfortable with. Okay, so pounds cancel, I'm left with kilograms, so then I do the math. So I have 34 divided by 2.205, which is 15.42 kilograms. So 34 pounds is going to be the same as 15.42 kilograms. Okay. Now let's say I have 45 miles per hour to meters per second. So this is what I want. This is what I have. So I want meters per second. So because I have 2, I'm going to start with the numerator. So I need to know something with meters. And I know I eventually want to get to miles. So I look in my table, and do I have a conversion between meters and miles? I don't, but what I do have is miles and kilometers. Okay. This one, same number of digits. I'm just going to pick this first one then to use. Now this isn't exactly what I want, but remember in the metric system, it's really easy to convert between the two. As long as you have the same second letter here, it's really easy to convert. So I'm going to start with this one. So I don't have meters, but I do have kilometers. I'm going to go ahead and write this down here. So I have 1 mile and 1.6093 kilometers. Now I can't use this just yet because what I want is meters. So I need to get from meters to kilometers. So if we go back to our table, from meters to kilometers, we're going to have to go over 3. Now whether you go left or right depends on where you put the 1. I suggest putting the 1 on the bigger unit. So in this case, the kilo is bigger than just the regular unit. So I'm going to say 1 kilometer. And then I'm going to convert that to meters. So 1 kilometer here, if I'm going to get back to meters, I have to move the decimal to the right 1, 2, 3 times. So that gets me 1,000. So kilo is a really common prefix. So if you can remember that kilo means 1,000, that'll save you a little bit of time here. So 1 kilometer is 1,000 meters. Okay, so now I have kilometers here. So now I can use this piece here. So I have 1.6093 kilometers for 1 mile. So kilometers cancel. Now I have miles, and I don't want miles in my answer. I just want the meters. So I can see what else I have, and here I have this 47 miles per hour. So I can do 47 miles per 1 hour. Now miles cancel. So I have meters per hour. Well, I don't want hours, I want seconds. So I know I need hour up here to cancel. Now I don't know exactly how many seconds are in an hour, but I do know how many minutes are in an hour. So I know that 1 hour is 60 minutes. And I do know that 1 minute is equal to 60 seconds. So hours cancel, minutes cancel. Now I'm left with is meters in the numerator and seconds in the denominator, which is what I want. So I can do my math. So remember, you can either multiply everything on top, multiply everything on bottom, and then divide. Or you can multiply everything on top, divide by 60, hit enter, and then divide by 60 again, and hit enter. And you should get 21.02 meters per second. Okay, example 11, 200 cubic centimeters, 2 cubic inches. So again, this is what we want. This is what we have. So we want cubic inches. Okay. Well, do we have a conversion between inches and centimeters? We do here. So again, you can pick whichever one you want. I'm going to go ahead and pick this first one. So 1 inch is 2.54 centimeters. Because that 0 is at the end, we don't really need to write it. So I know that 1 inch is 2.54 centimeters. Remember, this is the regular inch in centimeters, and we want cubes, so we're going to have to take this and we're going to have to cube it. So we have 1 cubic inch is going to be 2.54 cubed. So remember, in your calculator, you can use the caret and 3. You type in 2.54 and that little caret button and the 3, and you would get 16.387 cubic centimeters. So these are the numbers that go into my table. Okay, so now I want inches, but I don't want the centimeters, so I need something to cancel it out with. And well, I have this 200 cubic centimeters. There's nothing else with it, so I can go ahead and multiply. So I have 200 divided by 16.387 to get 12.2 cubic inches. Okay, so let's say we are looking at energy and power. Let's look at the units that are mostly used for that. So energy is what makes matter move, or what makes them heat up. So units of energy, we're going to use, it's called a joule. This is the basic unit of energy. Power is going to be a rate that the energy is used. So a unit of power is going to be a watt. Now a watt is actually equal to 1 joule per second. So if it's like 60 watts, that would be like 60 joules per second, the amount of energy used in each second. So then a kilowatt hour is a unit of electrical energy. So remember, kilo, even though watt isn't like a typical metric thing, we still use like the same units here. So a kilowatt is going to be 1,000 watts. Notice here we have a hyphen, so that means it is kilowatt times hour. Okay, so let's look at an example using this. So let's say your utility company charges you 13 cents per kilowatt hour of electricity. So what then is the daily cost of keeping lit a 100-watt light bulb for 12 hours each day? How much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light using only 25 watts of power? So now we have two questions. We're going to have two different answers. Let's look at the first one. So the first question is, what is the daily cost of keeping lit a 100-watt light bulb for blah, 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 blah. So daily cost, what does daily cost mean? So remember, anything that ends in like that ly, so daily or yearly, weekly, that is another way of saying per. So what we want here is a cost per day. And then the rest of it is just information about what's going on. So if we go back and look at the halves, so starting from the beginning, the first unit we come across is cents. So we have 13 cents per kilowatt hour of electricity. Okay, what is the daily cost? That's here of keeping lit a 100-watt light bulb. So we have a 100-watt light bulb, and we're using that for 12 hours each day. Now note we have different units of time here. We have 12 hours per day. Well, normally when we talk about hours per day, we're talking about 24. But remember, we're not just talking about the number of hours that passes during the day. This is going to be your run time. How many times or how long you have actually run this light bulb. Same thing here. The kilowatt, you only get charged for what you actually use it for, so this is also going to be run time. And this day is just going to be your basic unit of time. Okay, and that looks like it is everything up to that question. The next question provides different information, but we'll get to that when we get to that question. So we want the amount per day. Well, we start with the numerator. So we want something in dollars. And we look in our have list, and we have a cost per kilowatt hour. So we know it's 13 cents per kilowatt hour. So I don't want kilowatts or hours in my answer, so I'm going to first get rid of the kilowatts. Now I don't have anything else in kilowatts, but I do have watts. And remember, we can convert between watts and kilowatts. And so remember, we're going to put the one with the bigger unit. So just for ease, otherwise you would have a decimal. You can put on either one as long as you convert it correctly. So 1 kilowatt, kilo means 1,000. So if 1 kilowatt is going to be 1,000 watts. Okay, so that takes care of kilowatt. I'm going to go ahead and finish this one off before I go back to the hours. So for watts, I do have this 100 watts here. So watts cancel, there's nothing that goes with the 100, it's just the 100. So now everything else is canceled here except for hours. So I need to do something with this hour. Note, remember that this hour was your run hour. So we need to have another run hour. And we do have this. We have this 12 hours per day. So I have 12 hours for one day. So hours are canceled. This is just the day of the year. And again, this is also the day of the year. I just want to know how much we're going to have to pay every day. So everything is canceled except for what we want. So I do 13 cents times 100 times 12, and I divide by 1,000, and I get that this is going to cost $0.156 per day. So 15.6 cents every day to run this light bulb. Okay, so that is the first question. The second question, how much will you save in a year? Okay, if you replace the bulb with an LED bulb that provides the same amount of light using only 25 watts of power. Okay, so how much will you save? So this one, it's not asking for a direct cost. They want a savings. So that's for the first question. The second one, they want a savings. Well, how do we figure out a savings? We take the higher cost and we subtract the lower cost. And that's going to be the amount that we save. Well, we need to know exactly how much time we have. In that case, we want to save in a year. So what we're going to do is, if we can find the cost for each per year, then we can subtract them to get the savings per year. So we want a dollar amount per year in savings, and we're going to find that by finding the higher cost per year and subtract off the lower cost per year. So the higher cost, of course, is going to be the one that uses the more energy a day, so this 100-watt light bulb. Then we're going to subtract off the one for the 25-watt light bulb. So first we need to figure out, we already have this, that's 15.6 cents a day for this higher cost bulb, so let's figure out how much that would cost us in a year. So we can take 156 per day. We want $1 per year, so we start with the dollars, and we need to convert the day to year. So we know that there are 365 days in 1 year. So days cancel, so I have 1.156 times 365, and I get $56.94 per year. So that light bulb is going to cost me $56.94 per year. Now let's see how much it would cost if instead we have a 25-watt light bulb. So again, we have the same cost per kilowatt hour. And we're going to do the same kind of thing we were just doing. So last time you need to get to kilowatts. This time, instead of 100 watts, we have 25 watts. But I need to convert, just like we did before, from kilowatts to watts, and then I can put my 25 watts here. So now watts cancel. Now I get from hour, this time instead of from hours a day, we're going from hour to year. So we have, well, 12 hours a day that it's being run. And then 365 days per year. So days cancel, hours cancel. So now we're left with a dollar amount per year. So we do 13 cents times 25 times 12 times 365 divided by 1,000, and I get $14.24 per year. So remember, we want the savings, not either one of those answers. So we're going to take our $56.94 and subtract off $14.24. To get 42.7. So in that year, I saved $42.70 on my bill. Okay, similar example. This time, let's have a clothes dryer that uses 4,000 watts of power. You run it for an average of an hour each day. If you pay the utility company 14 cents per kilowatt hour of electricity, what is the average daily cost to run the dryer? And again, how much would you save in a year if you replace it with a more efficient model that uses only 2,000 watts? Okay, so again, we have two questions. They want, what is the average daily cost to run the dryer? Again, so we have a daily cost, so we want a cost per day. What we have, it uses 4,000 watts of power. So in other words, that's 4,000 joules per second. You run it for an average of 1 hour each day. Remember, this is the run hours per 1 day. You pay the company 14 cents per kilowatt hour. And that is it for that question. Okay, so just like we did before, we want dollars, so we're going to start with my dollar amount, 14 cents per kilowatt hour. Again, that is run hours. So I need a run time, so it's 1 hour per day. Now this time, notice I start with the hour. It really doesn't matter which one you start with, as long as you take care of both of them. So hours cancel enough for the day, which is what I want. So now I can go back to my kilowatts to take care of that. I don't have any more kilowatts here, but I do have watts. So I know 1 kilowatt is 1,000 watts. And I have 4,000 watts here. So kilowatts are gone, watts are gone. Nothing here because there's nothing there. So I can go ahead and multiply across. So I have 14 cents times 4,000 divided by 1,000. And that gets me 56 cents per day. So that's how much it costs to run that dryer every day. Okay, so now it says how much we would save in a year. So again, we have a savings question. So we need the higher minus the lower amount. And we want to save again in a year. So we want a dollar amount per year. So we're going to take the dollar amount for our 4,000 watts in a year, and we're just going to subtract off the dollar amount for our 2,000 watts each year, because we're looking at something that's 2,000 watts. Okay, so to figure out how much this first one will cost in a year, I take how much it costs in a day, and I convert my days to a year. So 56 cents times 365 is going to be $204.40. To figure out how much my new model will cost, I'm going to take do the same thing here, but instead of 4,000, I'm going to have 2,000. So convert the hour, or 1 hour run per day, convert the kilowatts to watts, and this time I'm only using 2,000 watts instead of 4,000 watts. So again, so I have 14 cents times 2,000 divided by 1,000, and I get 102.20 per year. So to get the savings, I take 204.40, subtract off 102.20 to get a savings of $102.20. Now, does it make sense that this is the same thing as that? In this case, yes, because we're using half as much energy, so it should cost half as much. Okay, so other things we use units for, density and concentration. Density is going to be the compactness or thickness of something. So how dense it is, how thick it is. So think like a bowling ball versus a soft or like a basketball, where they have almost the same size, but the bowling ball is a lot more dense because there's a lot more material in that volume than there is in a basketball. So material density, we're going to be using units of mass per unit volume. So like, for example, like the basketball versus bowling ball, we're going to say, okay, how much of mass, so like how much does it weigh, the pounds or grams, per volume or size of it. So for example, we could say grams per cubic centimeters. Or you could say pounds per liter, or any similar units to that. For populations, we're going to say the number of people per area, For example, the number of people per square mile. So say how closely, um, how many people are in there, how close together are they? Are they spread out, or are they more densely packed together, like in New York? New York would be a lot more dense than, say, some place in like South Dakota. Okay, information density. So this is going to be the amount of memory per unit area. So for example, the number of gigabytes per square inch. It's like the like on the motherboard or whatever. So let's say we're going to ask you for something. So let's say example 14, the country with the highest population density is Monaco, where approximately 38,000 people live in an area of 1.95 square kilometers. What is the population density of Monaco in people per square kilometer? Compare this density to that of the United States, which is approximately 35 people per square kilometer. Okay, so first question, what is the population density of Monaco in people per square kilometer? So we want people per square kilometer. So what we have here, we have that there are 38,000 people in an area of 1.95 square kilometers. So in the same patch of area, we have 38,000 people, and we also have 1.95 square kilometers. So these are describing the same area, so I can put them together as a fraction, and that's actually the units I want, people per square kilometer, so I go ahead and do that division, and I get 19,487.2 people per square kilometer. So that's the answer to the first question. The second question, compare the density to that of the United States, which is approximately 35 people per square kilometer. So the US has 35 people per square kilometer. So to compare, we can say how many times greater is that. So to figure that out, you take the take Monaco and divide it by US. So if you take 19,487.2 and divide by 35, we end up getting 556.8. So Monaco is 556.8 times more dense than the US. And we'll talk more about how to find this information in Chapter 3. Okay, concentration. Concentration describes the amount of one substance mixed with another. So, especially like for medicine, it'll be how much medicine in that amount of liquid. So you can talk about air pollutants, you can talk about blood alcohol content, talk about medicine dosages. Example 5, let's look at some medicine. So the antihistamine Benadryl is often prescribed for allergies. A typical dose for a 100-pound person is 25 milligrams every 6 hours. Part A, following this dosage, how many 12.5 milligram chewable tablets will be taken in a week? So, what is it that they want? How many 12.5 milligram chewable tablets? Okay, so we have a couple different units here. We have milligrams and we have chewable tablets. Now, since there's no word in there, it just means that they're both describing the same thing. It's two things, there's two different ways of describing something, right? So we have tablets that are 12.5 milligrams. So that is, this together says that there are 12.5 milligrams in one tablet. They're both describing the same thing. So when I say how many 12.5 milligram chewable tablets will be taken, what I'm really wanting is the total number of tablets that would be taken. And when it says in a week, you can say number of tablets per week, or you could put that week here. I suggest put it in the halves. It does make a tiny bit of extra work at the ending, but there are some cases where it's actually more clear to put it this way. Because it says in a week, so it's kind of just like describing other things that you have and not like, it doesn't say a weekly amount. So we have a week. Well, let's see, what else do we have? Well, we have that this 12.5 milligrams per tablet. Earlier on, it says a typical dose for a 100-pound person. So we have a 100-pound patient. And then we have 25 milligrams. Every is another way of saying per 6 hours. Okay. Now we may not use all this information, and that's okay. So we want number of tablets. So we're going to start with tablets, and I'm just going to abbreviate tab. So looking in here, I've got that one tablet is 12.5 milligrams. So one tab is 12.5 milligrams. Looking for something else with milligrams, I have 25 milligrams in 6 hours. Oops. Um, 25 milligrams in 6 hours. Okay, so milligrams cancel. Now I have hours that I want to get rid of. So I've used those two. Well, I don't have any more hours. I do have a week, so I can get from hours to week. So I know that there are 24 hours in a day, and there are 7 days in a week. So days cancel, hours cancel. I'm left with tablets per week. I don't want weeks in my answer, so here I can use my 1 week here. So here everything is canceled. I haven't used this 100 pounds, but that's okay, because we're just going to follow the same dosage. Now if it gave us, it said how much would be taken in a week for a 200-pound person, that would be a little bit different, but we don't have that. So I'm not going to use that one. So let's go ahead and multiply it out. So we have 25 times 24 times 7, and then we're going to divide that by 12.5 and divide that by 6. And we end up getting 56 tablets for that week. And that would be the answer to A. For B, Benadryl also comes in a liquid form with a concentration of 12.5 milligrams per 5 milliliters. So if you have a 5 milliliter dose that you drink of the liquid, 12.5 milligrams medicine will be in that. Following the prescribed dosage, how much liquid Benadryl should a 100-pound person take in a week? So they want how much liquid. So in that case, they want to know how many milliliters are we going to end up taking. So we have some of the same information. We're again looking at a 1 week. And this time though, we have a concentration of 12.5 milligrams in 5 milliliters of liquid instead of the tablet. Now we have a 100-pound person, but it matches this 100-pound person, so that's a hint that we're not going to be using this. And again, we have the dose of 25 milligrams every 6 hours. So this time I want milliliters, so I'm going to start with milliliters. So I know in every 5 milliliters there are 12.5 milligrams of medication. And again, I know that I need 25 milligrams every 6 hours. I know there are 24 hours in a day and 7 days in a week, and I have 1 week. So weeks cancel, days cancel, hours cancel, milligrams cancel. So then I multiply everything, which is basically the same thing as what we had before, but this time we also have this 5 here. So in that case, we have 280 milliliters for that week. Let me write that so you read a little bit better. That's 280 milliliters for that week. Alright, last example. Suppose a penicillin dose of 9,000 units per kilogram of body weight, taken every 6 hours, is prescribed for treatment of bacterial infection. For penicillin, 400,000 units is equal to 250 milligrams. So express the dose in milligrams per kilogram of body weight. Okay, so in this case, what we want then is going to be express the dose in milligrams per kilogram of body weight. So we want milligrams of medicine per kilogram of body weight. Notice they're both grams, but we're comparing different things. So this is the medicine and this is the patient. Okay, I'm going to put my have list up here. So we have a dose of 9,000 units per kilogram of body weight. It also says taken every 6 hours. So remember, every is another word of saying per. So we have 9,000 units per kilogram per 6 hours. And remember, when you have two pers in a row, you're going to put the second one in the denominator. So 9,000 units per kilogram times 6 hours. And then we have treatment penicillin 400,000. Yeah, 400,000 units is equal to, which means we can divide it by 250 milligrams. Why that is, the cursor looks like that, I don't know. I don't know. Anyway, okay, looks like that is all we have. So what we want is milligrams per kilogram, so we're going to start with this milligrams. So what we have for milligrams is here, so we have 250 milligrams per 400,000 units. Now I don't want units in my answer, so I have this 9,000 units per kilogram per 6 hours. Okay, so my units cancel. You might notice that we have this hour here and nothing really to tell us what to do with that. So let's go ahead and just multiply this out, and then I'll kind of tell you how we're going to deal with that. So we have 250 times 9,000 divided by 400,000 and divided by 6. Actually, hold on. What we're going to do here, because it's not asking for any amount of time, we're actually only going to worry about the this first part, the 9,000 units per kilogram. So I don't really care about the time component of it now. So I just do the 250 times 9,000 divided by the 400,000. And so we get 5.625 milligrams per kilogram of body weight every 6 hours. Okay, part B. How many milligrams of penicillin would a 20 kilogram child take in 1 day? Okay, so now that says how many milligrams of penicillin. So this time what they want is just milligrams. Now this one we do have a time component. So in our have list, we are including this 20 kilogram child, and we're including 1 day. We want to do it in 1 day. So we have our dosage. So we've already combined these two a little bit as this one. So I'm going to say we have 5.625 milligrams per kilogram, but this time we are looking at hours, so I'm going to include that times 6 hours here. Now I need to get rid of both the kilograms and the hours, so I have 20 kilograms here for the patient. So my kilograms cancel out. To get rid of my hours, I have to go to days. So I know that there are 24 hours in 1 day. And then I'm going to, I'll have myself there. Now that I have 1 day. So my days cancel, my hours cancel, kilograms cancel. I'm left with milligrams, so I have 5.625 times 20 times 24 divided by 6. So times 20 times 24 is 6. To get 450 milligrams. So that's how much that one child would take for the entire day. Okay, and that is it for 2B.